In this video, we actually want to confirm or derive this particular formula. And this is probably one that your instructor, your calculus instructor, expects you to memorize or know. But you can derive this formula using a trig substitution. This simply tells you that you got any kind of integral like this, and you can have a constant here, 3, 7, 8, 90, whatever. It's still going to work. You simply bring the constant out here in front. You put the constant out here, and then this, of course, will give you this formula here. And of course, you have your constant of integration. So let's derive this formula. And as usual, you can stop the video and try to do it. I'm going to say that tangent some angle theta equal to u over a. So I've got a right triangle. This will be theta here. Then over here I have u. This will be a. And this will be the square root. The hypotenuse will be the square root of a squared plus u squared. And then from this equation here, I'll let u multiply both sides by a. U will come out to a tangent theta. So taking the differential derivative here, it will be du will equal to a, and then derivative tangent is secant squared theta. And this will be d theta. So again, we want to show that this, of course, is equal to this. So I'm just going to, instead of rewriting this whole thing, I'm just going to put the equals over here. And I'm saying that du over a squared plus u squared will equal to, using these substitutions over here. And let's look at the denominator. We have a representation for du. That's this right here. And then in the denominator, let's look at a squared. We got a squared plus u squared, but u squared, or u is a tangent theta, so let's just square this a tangent theta, and I get a squared tangent squared theta. Okay, factor out a squared out of that. We get a squared parentheses 1 plus tangent squared. Anytime you're dealing with trig substitutions, makes it a little bit easier for you to know those basic fundamental identities from trig. So you should recognize 1 plus tangent squared theta as secant squared. So this simplifies to a squared secant squared theta. So let's go back to this then. We want to show that du over, the integral of du over a squared plus u squared is equal to this over here. So let's go ahead and just put the integral sign here. And then the du is right here is a secant squared theta d theta. And that's over the a squared plus u squared, but that's equal to a squared secant squared theta. So now let's just simplify this. Secant squared theta, that cancels out. I got an a squared here, and, or a up here, and a squared here, so this goes to 1 there. So this just gives me the integral 1 over a. I just bring this out to the side, or outside rather, the integral sign. That's constant, so it's 1 over a. And then all I'm left here is 1 d theta. And then we integrate with respect to theta here. So that's going to give me 1 over a theta plus the constant of integration. And then we continue here then. We want theta, we got tangent theta right here, is equal to u over a. So if I take the tangent inverse of both sides here, or arctangent, it's the same thing. Sometimes you see it written arctangent, and sometimes they'll say tangent inverse with a -1 here. Same thing. So in this case, theta then will equal to, I'll write it over here, arctangent of u over a. So just replace it here. This then is 1 over a. And then the theta then is arctan of u over a. Plus the constant of integration. And this is the confirmation, or actually deriving this particular formula that leads to a integral being 1 over a arctan of u over a plus the constant of integration. Thanks for watching. We'll see you next time.